We're now going to look at the superposition theorem. In a linear circuit, and by linear we mean that it has a constant voltage sources or constant current sources, the current and the voltage drops for any element in the circuit is the sum of the currents and voltages produced by each of the sources acting independently. And in order to do that, we have to remove all of the sources but one and do the calculation, then do the same thing for each of the sources in the circuit. And the question arises then, how do we replace or remove a source? Well, a voltage source, when you remove it, is replaced by a short or just a wire in the circuit. A current source is replaced by an open, just as if you just extracted the element of the current source. The best way to demonstrate this is with an example. Our example is made up of two sources, one a voltage source of 20 volts and a current source of 8 amps. And we have three resistors, a 2 ohm, 3 ohm, and a 5 ohm. Our task will be to find the voltage drop across the 2 ohm resistor. Okay, the first thing we do is replace the 8 amp current generator and replace it with an open circuit, of course, and that leaves us with a 20 volt power supply feeding a 5, 3, and a 2 ohm resistor in series. The next step will be to replace that voltage generator with a short circuit, and that will leave a current generator feeding two parallel circuits, a 5 ohm to the right and a 3 plus a 2 ohm to the left. Going back to our first circuit, we can calculate the current flowing in that circuit by simply using Ohm's law, which is I is equal to V over R, and V being 20 volts, and the R being a sum of 5, 3, and 2 ohms, which is 10 ohms, which would leave us with 2 amps. So 2 amps flowing through a 2 ohm resistor would give us a voltage drop of 4 volts. In the bottom circuit, the current generator is split between current going to the left and current going to the right. And in these circuits, it just so happens that to the right is 5 ohms and to the left is 3 plus 2, which is also 5 ohms. So you get an equal split of the current, half going one direction, half going the other. And that gives us 4 amps going through the 2 ohm resistor, and that would provide a voltage drop of 8 volts. So we then arithmetically add the two answers that were gained independently, 4 volts plus 8 volts, to give us 12 volts. Stay tuned to this site, as I'll be diving into more information from my electrical courses. In the meantime, take advantage of the availability of my 50-page electrical power crib sheets by simply filling out the information when you go to this website, https://bit.ly/47 uppercase y, uppercase b, 3 lowercase v, and lowercase h. You can also directly access my StanStore courses at this website, https://lowercase stan.store/uppercase G, uppercase V, uppercase B.